Hello everyone, welcome to today's video lecture of object-oriented programming using Java. The paper code is CS504A. This is Shayani Chandra, Assistant Professor of Department of Computer Science and Engineering of Guru Nanak Institute of Technology. Let's look at today's lecture contents. Today we will learn about member access and inheritance, that is how the access specifiers can be applied before a class member, and if it is applied, then how those members can be inherited. What happens if you want to implement inheritance in that case? The next topic of our today's lecture is super keyword and super method, which we have left in the last lecture. So today we will discuss about these two things, how the keyword super can be used as a keyword only and also as a method. The third topic of our today's lecture is multi-level inheritance, how to incorporate multi-level inheritance in a Java program. And then we will see when the constructors will be executed, in which form they will be called. So let's go to the first topic of our today's lecture, which is member access and inheritance. We all know that in a Java language, there are four access specifiers, which are public, private, protected, and default. So these access specifiers can be applied before a variable or before a method or before a class. Now, if you apply these access specifiers before a class member, be it a variable or a method, and if it is the superclass, then if you want to inherit that superclass in a subclass, then what will happen? Suppose if we are using the private access specifier before a superclass variable, then can it be inherited or not? Or if we apply some other access specifiers like public or protected before a superclass variable, then can we inherit or not? If it can be inherited, then what can be the constraints or what can be the restrictions, that we will discuss in our today's lecture. So let's do a simple program to make you understand how the access specifiers can be placed before a superclass member, and if it is so, then how the inheritance concept can be implemented in that case. So this is a simple program. This program is same as the last lecture's program, where this A is the superclass, this B is the subclass because extends keyword is used after it, and these are the superclass contents. I is an instance variable. It has no access specifier before it, so it will be assumed to have default access specifier. Then after that, another instance variable, which is j, is there, and before it we have used the private access specifier. Then there is a show method that will just print the values of I and j, and before this method no access specifier is there, so the compiler will assume that there is a default access specifier. Now this B is the subclass, and these are the contents of the subclass. This is the instance variable of the subclass B, and this void display method will print the values of I, j, and k. Now we know that in case of a private access specifier, the private member can only be accessed within the class within which it is defined, and here also the same concept will be applied. That means this j variable can only be accessed within the scope of this A class. Outside this A class, this j variable cannot be accessed directly, or even if you create an object of this A class, then also using that object you cannot access j, as because it has been made private. So here B is the subclass, so it will inherit all the properties of this A class. That means I, j, and all the things. It can be called or accessed directly from inside this B class, like here. That's what we have done here. We have called I directly, J directly, and K is the member of this class itself. So even if there is an inheritance, the private member will not be inherited because it is a private member, so it cannot be inherited because private access specifier says that it can only be accessed within the class within which it is defined. So even if B class inherits all the properties of A class, the private member cannot be inherited. So whenever you want to access J, which is a superclass member from the subclass, it will give you error. That's why here this comment is being shown as error, because here we want to access J, which is the superclass member which has been made private, and private member cannot be inherited because of the constraint that has been applied on private members. Similarly, when here you want to give some value into the J variable, the sub OB is the object of the subclass. This is the main class actually, this is the main method. And using the sub OB object, we want to put some values into the three variables I, J, K. You can easily put value into I, into K also, but into J it's not possible because it has been made private here. So this statement also is going to give you an error. That's why in the comment error is written. So this is the thing that will happen whenever you want to inherit a private member. Private members cannot be inherited, whether it is a variable or a method. Any of them cannot be inherited because of the fact that private access specifier is limited. Its access is limited within the class within which it is defined only. Outside that class, private members cannot have any access. That's why private members cannot be inherited. But if it is a default member or if it is a private member, they can be normally inherited. There will be no problem in inheriting default or public members of a class. Like you can see that this I is an instance variable of the superclass A. It is a default member. Similarly, this show is also a default member. If you make it public, say if I am making it public like this, if you make it public, then also it will be inherited normally, just like a normal default member. So default member and public members will be inherited normally. There will be no problem in inheriting default or public members, but you cannot inherit private members. If you want to do so, then it is going to give you error. So now let me compile this program and then execute the program to show you the output. So these are the errors that I was talking about. Whenever you want to compile this program, this statement is going to give you error. This arrow indicates the location where the error has happened in the statement, and the description of the error reads like J has private access in A. That means as because in the superclass A, J has private access, so it cannot be accessed or inherited like this. So this is where the error has actually happened in this statement. The next statement, whenever you want to access J in order to give some value into it, then also it's going to give you error, just as I explained. So this statement, in this statement here, there is the problem. That's why this arrow is locating this position where the error has occurred, and this is the description of the error, which reads like J has private access in A. So these are the two locations where we want to access a private member of the superclass, which cannot be accessed or cannot be inherited. That's why these are giving you errors. Now you can see that I has been made public, so I can be inherited normally, and K is the instance variable of this class itself, so no problem in printing it. Similarly, this show method is made default. It has no access specifier before it, so it has been made default. So it can be easily be called using the subclass object, because this default method has also been inherited inside inside the subclass B. and the display method is of the subclass itself, so no problem in calling it. That means the show method, which is a default method, and the I variable, which is a public variable, they are being inherited normally like the other inheritance programs. But as J is a private member or J is a private variable, so it cannot be inherited. So this is how the member access or the access specifiers applied before a superclass member um, do have effect on inheritance. The next topic of our today's lecture is super method and super keyword. So let us change the same program a little bit to make you understand how super method can be implemented in a Java program. After that, we will go into the program of super keyword. So this is the same program that I have done using default constructors, and I have removed the private access from the J variable. So now all the members of the superclass A have default access. IJ, the constructor, and show, all of them have default access. So what I'm doing here is that I have taken a default constructor of the superclass A, and I have assigned a value 10 into the instance variable I and a value 20 into the instance variable J. And then the show method is being used in order to print the values of I and J. Now B is the subclass, K is the instance variable of the B subclass, and this is the default constructor of the subclass. Now inside the B constructor, we have assigned a different sets of values into I and J, 3 and 6 into I and J, and 9 into K. Then we have the display method inside the subclass B, which will print the values of I, J, and K. So this is the main class, this is the main method, and this is the superclass object subob. Using the object we have called the superclass method show in order to print the values of I and J, which will print like 10 space 20. And then the subob is the subclass object that has been created, and using the subclass object we have called the superclass method as well as the subclass method. So by calling the superclass method, we will print the values of I and J as 3 space 6, and by calling the display method, we will print the values of I, J, and K as 3 space 6 space 9. So there will be three outputs in this program: 10, 20, 3, 6, and 369. Just as I told that there will be three sets of outputs here: 10 space 20, then 3 space 6, then 3 space 6 space 9. Coming back to the program, I have changed a little bit here. Suppose we want to assign the same set of values 10 and 20 into I and J inside the subclass constructor also. So inside the superclass constructor, we have assigned the values 10 and 20 into I and J. Now here inside the subclass constructor also, we want to assign the same set of values 10 and 20 into I and J, then 9 into K. Now here you can see that in order to assign the same set of values 10 and 20 into I and J, we have to write down the same code that we have written here again here. But inheritance is basically used to implement the code reusability feature of Java that we have already discussed in the last lecture, where we have given a basic concept of inheritance. So here, if we need to write the same code once again, then what is the use of the code reusability feature? If we are using inheritance, then there should be an advantage of using it. There should be the code reusability feature being implemented so that we don't need to write the same code again and again. But here we have to do so. That's because we want to assign the same set of values 10 and 20 into I and J. So in order to achieve this, that means in order to input, or in order to store the same set of values into the same variables again and again, it- you don't need to write the same code that you have already written inside the superclass constructor here again inside the subclass constructor. That's because the code reusability feature is there, as because you are implementing inheritance. That means this code that you have once written can be used here also. That's the use of inheritance in Java. That's the feature of code reusability in Java, that you don't need to write the same code again and again. So you have written this code here, so you don't need to write this code here again. What you will do, you will use the super method here instead of writing the same set of statements here. Instead of writing the same couple of statements here, these two statements here again, you will use this super method. So here comes the use of super method. This is a method that's because of the reason that it looks like a method, because it has a pair of opening and closing parentheses after it. That's why this is known as super method. The keyword is super, and as because we are using the opening and closing parentheses after it, so it is called a super method. Now, what is the use of this super method? Always remember that the super method should be the very first statement inside the subclass constructor. You can always put the super method inside the subclass constructor only. You cannot put it inside the superclass constructor. Super method is basically used inside a superclass constructor, sorry, subclass constructor in order to call the superclass constructor. I'm repeating once again. Super method is basically used inside the subclass constructor in order to call the superclass constructor inside the subclass constructor. So that's what we want to do here. That means we want to call the superclass constructor so that these two statements get executed here. Instead of writing it here again, we want to call this constructor here inside this subclass constructor B using this super method, so that these two statements get executed and we don't need to write the same code. That can be done if we use the super method here. The super method here, whenever the compiler will find out that the super method is placed here, it will directly go to the superclass constructor, that means here. And whatever codes are written inside it, the compiler will execute them once again here inside the subclass constructor B. That means the same code which says that the same value 10 will be assigned into I and the same value 20 will be assigned into J. These two codes, these couple of codes will be executed once again inside the subclass constructor if you use this super keyword here. But remember that the super method should be the first statement inside the subclass constructor if you want to call the superclass constructor from inside the subclass constructor. If you do so, then actually these two statements will be executed, which are written inside the superclass constructor, which reads like I equal to 10 and j equal to 20. That means the value 10 will be assigned inside I and the value 20 will be assigned inside j. After that, 9 will be assigned into k as it is, so it has no relation with the super method. The super method here will just call the superclass constructor, this one here, from here. And after calling the superclass constructor, whatever codes are written inside it will be executed. That means these two statements, that means these two will be executed here before the value 9 gets into the k variable. That means whatever we wanted to write here will be automatically done for you because of the code reusability feature. of inheritance. So you don't need to write the same set of statements that you have already written inside the superclass constructor. If you want to execute the same set of statements here from inside the subclass constructor also, you just need to call the super method, which should be the very first statement inside the subclass constructor, in order to call the superclass constructor. And if you do so, automatically whatever are written inside the superclass constructor will be once again being executed inside the subclass constructor also. So after that, the uh, void display method will print the values of I, j, and k. Then the main method is being used. This is the superclass object, which will call the show method of the superclass, which will print 10 and 20 as output. This is the subclass object, and this is how we call the show method using the subclass object. So by calling the show method using the subclass object, 10 and 20, as because super method has been used, so I will be assigned with a value 10, j will be assigned with a value 20 again. And if you call this show method, then that means the value of I and j will be printed as 10 and 20. And after that, if you call the display method, I, j, and k, all the values will be displayed as 10, 20, and 9. Because we have used this super method, so I will be assigned with 10, j will be assigned with 20, like the superclass constructor, and those values will get printed. So let's execute the program to show you the output. So these are the three sets of outputs that we can see on screen: 10, 20, then again 10, 20. These 10, 20 are being displayed because super method has been used, and lastly I, j, and k, all the values are being displayed. So this is how you can use the super method in order to call the superclass constructor inside the subclass constructor. That means whatever statements are written inside the superclass constructor will be once again being executed inside the subclass constructor, but you have to put it in the very first place inside the subclass constructor. Now you can do this whole program using parameterized constructor also. We have used here default constructors. Here A is a default constructor and B is also a default constructor, but we can do this program using the parameterized constructor also. Now let us do this. So this is the same program that has been done using parameterized constructor. Here you can see that A is the superclass. These are the two instance variables of the superclass. This is the parameterized constructor of the superclass. These are the parameters of the constructor. A has been assigned into the instance variable I, and B has been assigned into the instance variable J. Then this method show will print the values of I and J. Then B is the subclass, K is the instance variable of the subclass B. This is the parameterized constructor of the subclass B. And here we have used the super keyword or super method. This super method is a parameterized super method. In the previous program, you have seen the default super method, which was a non-parameterized one. And here you can see that this is the parameterized super method, because we are using parameterized constructors in both the superclass and subclass. So we have to use the parameterized super method here in order to call the parameterized superclass constructor inside the subclass constructor, which is also a parameterized constructor. So basically you are calling these two statements. You want them to be executed here, and here we have written x and y instead of a and b. That doesn't matter, you can write a and b here also. That means the variables or parameters here can also be a, b, and say c, because these are the parameters of the constructor A. And these x and y and z are the parameters of the constructor B, which have no relations in between them because they are local variables. So their scope and lifetime are limited within this constructor block only. So whenever you're coming out from this block, their lifetime is no more there. Their scope becomes um, they actually they don't be they are not going to be accessible anymore. So here also you can write a b and say c or anything else, or you can also write any other parameters like this, like I have written x, y, and z. So whatever parameter you will be writing here, that you have to put here inside the parameter of the super method. So if you put the parameter of the super method like this, then it becomes a parameterized super method. But remember that this should be the very first statement inside the subclass constructor, and whenever the compiler will find out this statement inside the subclass constructor, it will at once go to the superclass constructor, and whatever are written inside that constructor will be executed. So basically it will be executed like I equal to x and j equal to y, or you can also say I equal to a, or sorry, j equal to b. So these two statements will get executed actually. So whatever values you have given inside a and b, that will be assigned into I and j. But here whenever you are writing x and y, so whatever values you have given into x and y, that will be assigned into I and j. That's why I have written here I, x and y. That means whatever value you have given into x will be assigned into I, and whatever value you have given into y will be assigned into j. That means I equal to x and j equal to y, these two statements will be executed. So these two statements are same as these two statements, basically value assignment statements into the instance variables of the superclass. That code has been written here inside the superclass constructor. The same code will be executed here also, but with different values, nothing else. So super method can do this also. That means the same code will be executed, but with different values. This thing also can be done by using the super method. If you use here x and y, then these two statements will be executed but with different values. Instead of a and b, x and y will be assigned into I and j. So this super method here will actually call the superclass constructor in order to execute these two statements, but instead of assigning a and b into I and j, x and y will be assigned into I and j, because the super method has been called using the parameters x and y. Then the value of z will be assigned into k, and then this display method will just print the values of I, j, and k. Then this is the main class, main 7. This is the main class, this is the main method, and this is the superclass object. And in the superclass object creation statement, we have passed the values 10 and 20. So 10 and 20 will go into a and b, then into I and j respectively. Then when using this object, we are calling this show method. So basically 10 and 20 will get printed. Then the subclass object is subob, and in this object creation statement, we have passed the values 3, 6, and 9 into x, y, and z. So whenever the super xy method will be executed, then the compiler control will be at once transferred to the superclass constructor to call it and to execute the codes written inside it. So these two codes will be executed but with different set of values, and the values will be of x and y. That means I will be assigned with the value x, and j will be assigned with the value y. That means I and j will actually contain 3 and 6. Then the value of z, which is 9, will be assigned into k. And then using the subob object, show method is being called. So whenever show method is being called, this show method will be executed, and the values of I and j, which are 3 and 6 now, will be printed on screen. After that, the display method has been called. So whenever the display method will be called, this will be executed, and the values of I, j, and k, which are 3, 6, and 9, will be printed on screen. So this is what I have just explained. This should be the output: 1020 for the first call of show method, 36 for the second call of show method using the subclass object, and 369 for the call of display method. So this is how the super method can be used to call superclass constructor from inside the subclass constructor, but that statement should be the very first statement in the subclass constructor. And in the previous program you have seen that the super method has been used in order to call the superclass constructor in order to execute the same set of statements written inside the superclass constructor. And here you have seen that the super method, which is a parameterized method also here in this program, is being used to call the superclass constructor from inside the subclass constructor in order to execute the same set of statements written inside the superclass constructor but with a different set of values. So the set of values here used are x and y instead of a and b, which were written inside the superclass constructor. So super key method is basically used to call the superclass constructor from inside the subclass constructor. Now if you don't write this super method here, you have to write down these two statements here. So let me write it down. So if you don't write the super method here, you have to write down the these two statements, these two value assignment statements again inside the subclass constructor. But this is of no use because you have a super method with you already, so that you can use the code reusability feature that has been very much implemented using the concept of inheritance in Java. So you don't need to basically write these two statements again here, but let me show you the output. If you do so, what will happen? So here you can see that if we compile the program, it's showing us some errors. The error reads like constructor A in class A cannot be applied to given types. Required int found no arguments. Reason is actual and formal argument lists differ in length. Now let me explain you why this error is being shown. So if you don't want to use the super method, that means if you don't want to use the code reusability feature of inheritance in Java, you don't need to write the super method. Instead, you can write the same set of statements here again. But if you do so, it's showing you some error. There is a reason behind it because the subclass constructor by default calls the super method, the default super method. The subclass constructor calls by default the default super method with no parameters. That means what happens here actually is this is a parameterized superclass. This is a parameterized constructor of the superclass, and here no constructor is mentioned. But still, as I have just told that the subclass constructor by default, when no super method is being written here, here we can see that no super method is being written, not even the non-parameterized one. So when this happens, the subclass constructor by default calls the non-parameterized super method. That means by default, a statement like this statement like this is being executed. It's done by default by the Java C compiler. You don't need to write any code for this. So you can see that here no parameters are given. That means this is a non-parameterized super method. But here it is, so whenever this non-parameterized super method will be executed, it is supposed to call the non-parameterized superclass constructor from inside the subclass constructor. As because we have already discussed that using a super method will call the superclass constructor from inside the subclass constructor, and here you are using non-parameterized super method. Not you are using, actually Java C compiler is automatically using this super method call by default. So basically this super method should actually call the non-parameterized superclass constructor from inside the subclass constructor. But here you can see that the constructor that is being used inside the superclass is not a non-parameterized one, it is a parameterized one. So basically there are two parameters inside the superclass constructor. That means whenever you are making a call to the super method, you should have given two parameters inside its closing and opening and closing parenthesis, but you have not given any parameters because the compiler has by default inserted the super method here. That means the required parameters are should be int and int, but here the compiler has found that as no super method has been used explicitly, and as the Java C compiler has inserted the default non-parameterized super method call inside this subclass parameterized constructor body. So the compiler has found that the required number of parameters are of int comma int type, but here it has found that no parameters are given, so no arguments. So basically the required arguments are int comma int, but found that the Java C compiler found that although the required arguments are int comma int, but it has found that there are no arguments, and that is the reason that it's showing error. So let me show you the error once again. So this is what I just explained: required int but found no arguments. So this is the reason why it's being shown like this. The Java C compiler has found that the superclass constructor has two parameters which are of integer types. That's why required are int comma int. But as we have not specified any super method call explicitly, and as Java C compiler automatically or by default inserts non-parameterized super method call inside the subclass constructor in the very first statement, so it has found that no arguments are there. That means the actual and the formal argument lists differ in length. So the actual argument lists are actually int and int. Actual argument lists are required to be int comma int, but the formal argument lists where the call has been made, that means where the non-parameterized super method has been called, there are no arguments. So actually the argument lists are different in length. There should be two integer arguments, but it has been found that no arguments are there. That's why this is being shown as an error. Now this is the thing that Java C compiler automatically does for us. We don't need to write any code for it. So in order to correct this program, what we can do is that we should not write these two statements here. Instead, we have to make a call to the super method like this. So here, if you don't want to use the code reusability feature, then also you have to use it. If you don't want to use it, and if you want to write the same set of codes once again, you cannot do it because that is going to give you an error that I have just explained. So you have to use the super method here. And in my suggestion, there is no meaning of not using the code reusability feature. Obviously it's for our own ease of coding, so we should actually use the super method here. And the super method here will be more and more useful when you will find out that the superclass constructor has 100 value assignment statements written inside it. Then you don't need to write down those 100 statements here. You just need to write down this one statement in order to execute all those 100 statements. So this is the advantage of using the super method inside the subclass constructor. Let me tell you once again that the super method should be used in the very first statement inside the subclass constructor in order to call the superclass constructor from it. Now let us go to the next program, which will show you the use of super keyword, which is not a method, which will be used as a keyword only. So let us do the program. So this is the program which will implement the concept of super keyword in a program. Suppose there is a variable in a superclass. And also suppose that there is the same variable defined using the same name inside the subclass also. That means a variable which has been defined in the superclass has also been defined in the subclass, and both of them have the same names. Like here you can see that this is the superclass which has an instance variable named I, and B is the subclass which also has an instance variable named I. So if this is the case, then the subclass version of the variable will hide the superclass version of the variable. That means if there are two variables defined inside superclass and subclass, one inside superclass, another one inside subclass, then and if the names of both the variables are same, then the subclass version of that variable will hide the superclass version of that variable. Whenever you want to access the superclass version of that variable, you can never do that. You cannot even do that using the superclass object. In that case, you have to use the super keyword in order to access the superclass variable. So here keyword is being used in order to overcome this hiding of the superclass variable which has the same name as that of the subclass variable. So here you can see that this is the superclass variable I, this is the subclass variable I. So as they have the same name, so this I will actually hide this I. Now this is the subclass constructor, which is a parameterized constructor which has two parameters A and B. Both are of integer types. Now what we want to do here is that we want to assign the value of A into the superclass I, and we want to assign the value of B into this subclass I. So how can we do that? We can do that by using the super keyword before the I variable. So if we use the super keyword before this I variable, this will indicate that this I is the superclass I. And for the subclass I, we don't need to use any keyword. We just have to use the variable by its name. So if you do so, then the difference between them will be clearly understandable by the Java C compiler. That means here the super keyword is used to denote the superclass version of the I variable, which will then be assigned with the value A. And if you use the subclass version of the I variable with just its name, and then the Java C compiler will assume that this is the subclass I, then the value of B will be assigned into I. Then inside the show method, we are printing the values of both the variables. Here again, if you want to access and print the value of the superclass I, then here also you have to use the super keyword in order to access it. And if you want to print the value of the subclass variable, then you have to access it by its name only. This is the main class use super. This is the main method. This is the subclass object sub ob, and these are the parameters that are being passed to the subclass constructor. So one will be passed into A, then this value of A, which is 1, will be passed into I, that means this I, and then 2 will be passed into this B, and then this 2 will be passed into I, that means this I. And when the show method is being called using the same object, the both the values of both the variables will be printed on screen. So the output should be 1, and in the next line it should print the value of the subclass variable, which is 2. So just as I told, I in superclass colon space 1, I in subclass colon space 2. So these are the two outputs. That means this 1 is the output of the superclass I variable, and 2 is the output of the subclass I variable. So here we have learned that in order to access the superclass version of a variable which has the same name with that of the subclass variable, you have to access the super keyword, and in order to access it, you have to write down it like super dot variable name. So you have to access the superclass variable using the syntax super dot superclass variable name. So this is what we have done here. We have used the super keyword, then after that a dot operator is there, then after that the superclass variable name is written. So if you do so, the super keyword will prevent the subclass variable from hiding the superclass variable. If you use the superclass if you use the super keyword before the superclass variable, then it can be easily understandable by the Java C compiler that you are using the superclass variable which has the same name with that of the subclass variable. So this is another use of super keyword where the super is being used as a keyword only, which will be used as a method to overcome the superclass variable hiding by a variable with same name which is of subclass. So these are the two uses of super keyword that we have learned today. One as a super method that is being used to call superclass constructor from inside the subclass constructor, and another one that you have just learned is to call the superclass variable which has the same name with that of the subclass variable. Now let's move on to the next topic of our today's lecture, which is multi-level inheritance. So we have already discussed about this concept in the previous lecture, where you have already seen that multi-level inheritance denotes that there are multiple levels of inheritance. Here you can see that the first level of inheritance is between the two classes A and B, where A will be treated as the superclass and B will be its immediate subclass. And this is another level of inheritance where B will be treated as the superclass and C will be treated as its immediate subclass. And if this goes on, if this chain goes on, then it will be treated as a multi-level inheritance. So this concept that we can see here can be implemented using a Java program, and if we can do so, then it can be treated as an inheritance program which will implement the multi-level inheritance concept. So let us do the program to implement this inheritance in Java. So this is the same program that I have depicted in picture just now. There will be three classes A, B and C. So in between A and B, A will act as its superclass and B will act as its subclass, and in between B and C, B will act as its superclass and C will act as the subclass. So this is the superclass A. These are the two instance variables of superclass A. This is the parameterized constructor where values will be assigned into the instance variables I and j. This is the method show which will print the values of I and j. Now this is its subclass. This is the instance variable of the subclass B. This is the parameterized constructor of the subclass, and here super method has been used in order to call these constructor inside the subclass constructor, and then this k will be assigned with the value of c. This display method will then print the values of I, j and k. Then C should extend B. That means C should be the subclass of B and B should be the superclass of C. This is another instance variable of C class. This is the parameterized constructor of the C class where we have taken four parameters and then we have used the super method again using three parameters A, B, C. So this super method will in turn call the B class constructor, and inside the B class constructor we have used another super method to call the extreme superclass constructor, that means this one. So by using this super method we will actually call this constructor and this constructor too. Now this print value method will just print the values of I, j, k and l. Now here you can see that C can actually inherit the properties of A via B. So C is actually using I, j also, which are the properties of A class. That means C will be treated as the grandchild of the superclass A, and A can be treated as the grandparent of the subclass C. So C and A both are in an inheritance relation via B. So this is the concept of multi-level inheritance. Now inside the main method you can see that we have created the object of the extreme subclass C, as C can inherit both the classes B and A. it can directly inherit B, and it can inherit A via B. So by using the subclass object, by using the C class object only, we can access all the contents of B and A classes. So that's what we are doing. 10, then 20, then 30, then 40 will be passed into A, B, C and D. Now when super ABC will be called, this method, this constructor will be called. Inside it super AB is being written, so this constructor will be called. And like that, 10, 20, 30 and 40, all these four values will get assigned into the four variables that we have used in this program so far, which are I, J, K and L. So if we if we call the show method, which is the method of the extreme superclass A, then it should print the values of I and J as 10 and 20. Now, if we call the display method using the object of the C class OB, it should call this method, and the values of I, J and K, which are 10, 20 and 30, will get printed on screen. Now lastly, if we call this print value method using the object OB, it should print this method, which should print the values of I, J, K and L, which are 10, 20, 30 and 40 on screen. Now let me execute the program to show you the output. Just as I explained, there are three sets of outputs that we can see on screen: 10, 20, then in the next line 10, 20, 30, then in the next line 10, 20, 30 and 40. So this is how we can implement the concept of multi-level inheritance, multi-level inheritance in Java, where we can see that three classes we have used: A, B and C. So here C can actually access the B class directly, and it can also access the A class via B class. So this is how the concept of multi-level inheritance works. Now let us move on to the last topic of our today's lecture, which says the constructors will be executed in inheritance, but in what order will they execute? So when the constructors are being executed in an inheritance program, in what order will they be executed? Java says that the constructors in an inheritance program will be executed in the order of their derivation, be it a multi-level inheritance or a simple inheritance or hierarchical inheritance. The constructors will always be executed in the order of their derivation. Now let's do a program to make you understand this concept. So here in this program, we have used the concept of multi-level inheritance. The same concept is applied in simple inheritance or hierarchical inheritance also. But as I have just explained to you the concept of multi-level inheritance, that's why I'm showing this concept of executing constructors in a multi-level inheritance program. So here you can see that a superclass is being created, which is A, and this is a default constructor which is of the superclass A. Then its subclass is B, the subclass of A class, and this is the subclass constructor which is also a default constructor, and all these constructors will just print some values and nothing else, print some statements, sorry, and nothing else. Then we are creating a subclass of B, which is C. This is the subclass C's constructor, which will just print a statement and nothing else. Now this C subclass can directly inherit the B subclass, and via this B subclass it can also inherit the A subclass. Now this calling cons is the main class. This is the main method. Here we have created the small c as the object of the extreme subclass C. So let me change it for you for your better understanding. So this OB is the object of the extreme subclass C. Now when this object is being created, this part is the constructor calling part, we all know that. So whenever this constructor is being called, this constructor will be called. Now whenever this constructor will be called, the compiler will find out that this is the constructor of the C class, which is the subclass of the B class. So compiler will automatically go to its immediate superclass constructor, which is this constructor. Now, whenever the compiler will find out that this constructor is a default constructor of B class, which is a subclass of A class, the compiler will automatically go to its immediate superclass constructor, which is this one. Now the compiler is at this constructor, and it will find out that this is the extreme superclass of this multi-level inheritance. There are no more superclasses before it. So the compiler will start executing the constructors from this constructor one by one. That means at first this constructor will be executed, then this constructor will be executed, and after that this constructor will be executed. So even if you are calling the C class constructor, it is not like only this statement will be printed on screen as output. The statements that will be printed on screen as output are inside A's constructor, after that inside B's constructor, and after that inside C's constructor. This happens due to the reason that whenever constructors are executed in inheritance, they are being executed in the order of their derivation. Order of their derivation means that from where they are derived, that location will be executed first. So we can see that the C class has been derived from B. So B should be executed before C. Again, this B class has been derived from A. So this A class constructor should execute before B classes. Now this A class has not been derived from any class because this is the extreme superclass. So the constructors will start being executed from this class, and after that its immediate derived class is B. So after this statement is being printed on screen, its immediate derived classes constructor, which is this one, will be executed. After that its immediate derived class is C, so C classes constructor will be executed on screen. And that's why the output should be inside A's constructor, then inside B's constructor, and after that inside C's constructor, and not the one that has been printed inside the C constructor only. Even if we are calling the C constructor only, then also all the constructors will be executed in the order of their derivation. This is the concept that Java implements while calling constructors in case of inheritance. And this concept will be implemented while calling the constructors in case of all the inheritances that can be implemented in a Java program. So let me show you the output now. So this is what I have just explained, that the constructors will be executed in the order of their derivation, and the output should also be like that. So this is a wrap for today's class. In the next lecture, we will see how method overriding can be used in a Java program in case of inheritance, and then by applying method overriding, we will understand how runtime polymorphism can be achieved in Java. Thank you for listening to today's lecture. See you in the next lecture.